Tales from the days before credit cards were encrypted. This is Confluent Developer.
I spent a couple of years helping a large hospitality company protect the use of credit cards. There was concern about PCI penalties that they were going to start facing if they didn't get it resolved. There's a tendency to say, let's just throw everything out and start from scratch, and you just can't do that at that scale. As a 21-year-old, I was able to make a big difference. Like day one, and I'm like, what's our email address? And they're like, we don't have one.
Hey everybody, I'm Tim Berglund. Welcome to Confluent Developer, where we explore the journeys of software developers tackling really hard problems. Today, I get to talk to a very good friend of mine, Brian Sletten, about something early on in his career. Now, I've heard him tell this story before. We've talked about it, but I got to talk to him on air today about the time he helped a major hospitality chain actually add encryption to their stored credit card numbers. It's from a simpler time when that sort of thing is conceivable. It's a really tough problem, and although it seems like sort of an ordinary workaday enterprise software kind of problem, there's a lot of real interesting growth stories in there. So very important stuff. Let's listen in. Hello, everyone. I am your host, Tim Berglund. Welcome to another episode of Confluent Developer, where we explore the journeys of software developers solving hard problems. I could think of no one better for that topic than my guest today, Brian Sletten. Brian, welcome to the show.
Thank you. Happy to be here.
I'd like you to tell us a little bit about yourself, but start with what's the first job you ever had?
I graduated from the College of William & Mary in 1993. And,
William & Mary.
Yep.
Yeah.
Alma mater of a nation. It wasn't a particularly great time to look for a job. Nothing like it is now, unfortunately, for new grads, but still kind of the late 80s, early 90s. Wasn't a particularly great time. But I lived in the DC area, and a lot was going on. And back then, we used to look in the newspaper, classified ads for
Yes.
jobs. And I found this place that said, C and Unix, and it was located in Fairfax, Virginia. And I thought, why not? And it was a great experience. It was a small company. It was about 10 people, I think. It was called Barcom. It was a small communication software company. And they had built software interfaces to what were called network matrix switches. So, in large organizations with complex communications needs, you need to be able to patch in test equipment and particularly for military systems, run a communication channel through a cryptographic machine of some sort. And so rather than unplugging equipment, you would use the network matrix switch to activate one device talking to another device or setting up channels and things like that. And they all had ridiculous interfaces where you had to type out 40 character sequences and things like that. And so my company had created a commercial front end, motif based, sort of the X desktop of the corporate world back then.
Yep.
And so it was just kind of a point and click system. And it was a lot of fun, in part because a lot of the network matrix switches didn't have APIs or anything like that to control them. And so one of my first tasks was using Lex and parsing the print log console.
Yep. The garbage that came through the RS-232 port or whatever it was. Yep.
To verify that the commands and stuff were being done accurately and everything. But I did a variety of things for them, all kind of X and motif based, but also worked on some VME card communication stuff. And my first business trip was a 2-week trip to Guam for this company. It was fun. Went bungee jumping, all that fun stuff. But it was cool because as a 21-year-old, I was able to make a big difference. I showed up day one and I'm like, what's our email address? And they're like, we don't have one. And so I kind of got them onto the internet. And they were sending contracts back and forth by faxing them, and then retyping them, editing them, printing them out, and then faxing them back.
It's a peaceful life.
I came up with a mechanism. It was just a bit of a hack, but again, attachments couldn't be all that big back then.
Sure.
So I took the Word documents and I split them on byte boundaries and then sent them as attachments and then created a tool that they could reassemble on the other side. And, just they used to pay the executive assistant to hand draw complex motif screens using GemDraw. And I got them using screen dumps and things like that.
Yeah. So didn't know you could do that.
Yeah, and in addition to programming and everything, I did a lot of things like that.
Yeah,
it's also cool because it was the president was a woman, the senior engineer was a woman, my office mate was a woman, and my supervisor was a woman, and so I didn't really believe that there was a gender problem in our industry.
Yeah, looking around as this young man, you're like, looks great, right? Yeah. Broader experience is always helpful.
To see and the CS department at William & Mary was also at least half female as well. So nice. Again, it took me a while to kind of come to the conclusion that there was an imbalance.
There's the world you grow up in, and then there's the world that there is, and you have to see the difference between the two. I just want to say my first business trip, Guam is pretty good for a first business trip. Mine was to Dumas, Texas. So, not everybody gets to lead the charmed life I do. Although Dumas is a nice place. It's
I'm sure it is.
It's there's no bungee jumping because there's no elevation deltas, but
3 months after I jumped off that platform, it snapped and the operator died. So I
guess maybe that shows him
something to say about not bungee jumping. But
I'm so fully on board with the policy of not bungee jumping. You have no idea. So you are a career software developer, teacher, speaker, forward thinker. If that's all fair summary. Mm-hmm. You've done a lot of cool stuff. What do you think is the hardest problem you solved?
It's a hard question because, as you said, my career has largely been broken down into like really cool ahead of the industry by 10 or 15 years kinds of stuff, or kind of pragmatic, helping big companies avoid stepping on themselves.
Right, using Spring more effectively in their enterprise Java app, or 15 years ahead of the rest of the world. That is a completely fair description of you. Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now, back to the show.
I'd say the one that's probably the easiest to talk about in kind of tangible terms is I spent a couple of years helping a large hospitality company protect their use of credit cards. They, like everybody, were using credit cards inappropriately as keys in databases and in plain text in reports and things like that. And there was concern about PCI penalties that they were going to start facing if they didn't get it resolved. But we also kind of came in and helped them understand that the real risk was more the brand damage that would happen from a breach, more so than the daily penalties. And they wanted to know whether they had two approaches. One was to encrypt the credit cards, or to use something that they call the proxy number. And they wanted us to help them.
Briefly, the state when you got there, the former state was unencrypted credit card number stored in a database, and we won't use the name of the brand. Okay.
And there
Nothing
were
could
some
go
things
wrong.
that were worse than you could imagine.
Yeah.
I'll give you a hint about that in a minute. So the problem with encrypting the credit cards is now you have a key management problem,
Mhm.
but also the shape of encrypted credit cards looks nothing like credit cards. So now every table that stored credit cards, every report that printed out credit cards, every application that was expecting like a 16 to 19 digit number now would get modified to have a binary blob, right? And so
Right.
this is why this is, I think, worth talking about, is because it was a big problem and it touched a lot of systems. If you think about a hotel chain, everywhere a credit card can be used, reservations and gift shops and golf clubs and spas and entertainment and snack shops and whatever. Um, and they didn't even have like a comprehensive understanding of that. So the first 6 months, I had to interview all the teams and kind of build a vision for the architecture as it spanned systems across divisions and things.
So this
And
would be
that
also
was
the bad old days of there's one database and many clients that are accessing that database. So all of those, as you say, other ways of seeing a credit card, all of them would have to be updated with
yep.
how to decrypt and how to get the
Well,
key and all that
because
stuff.
the goal was to change the database, right? To
Yep.
use the protected form. And so if we'd had to touch all of that, that would have been an enormous integration activity. Would have been extremely costly.
Yes.
So we actually recommended they use the proxy number approach, not the way that they imagined it, but under what we would refer to these days as format preserving encryption. So it went through a cryptographically transformative process. We didn't design it ourselves. We worked with actual cryptographers to work on it. But the ciphertext ended up looking like plain text, right? In the sense that they ended up looking like credit cards.
Okay.
But they were cryptographically protected. You couldn't go from the proxy number back to the real one. But we also designed it into a three-way transformation and introduced a new set of business privileges that were missing as well. So if you're in the marketing department, you may care about which card somebody uses, right? Some Chase, MasterCard or something earns double points. So those sorts of systems in managing loyalty affiliation programs would have to be able to see that much of the credit card. And so the first transformation allowed you to get to the first couple digits of the card, which indicates the bank that it came from.
Okay.
But they had no access to the full credit card, right? It was just the beginning of it. Somebody at the front desk has to be able to validate what card is on file. So there was another transformation that would get you the last four digits. And therefore, a customer could say, is it the card number 2217 or something on file? And they'd be able to validate it, right?
Right.
But it was only the financial systems that had the ability to
The full
see all
number.
three transformations and to get to the actual credit card data for payment purposes. And so not only did we lay this blanket down over their entire system, because only the systems that actually needed some part of the credit card data would then actually have to be modified, because we were giving them something that looked like a credit card, even though it wasn't. And if they were just like storing it and passing through or using it as an identity or something like that, they could continue to do that because they were now protected through the cryptographic transformation.
Was that transformation one way? So even with the key, you couldn't take the plain text and go back, or you could?
No, with the key, it was a 3-part process, and
Okay.
there was a business privilege that was associated with it and keys associated with it.
Okay.
But you'd have to have all those pieces to do it. But we could delegate that to just the marketing systems or the front desk systems or whatever, and they'd only get to see part of it.
Yes, by key management, basically.
Right. So we laid this down, and systems that didn't need credit card access could remain untouched then. We then were able to take the centralized database, right, and convert it. And I was actually staying in one of their properties the weekend that happened, and I was waiting for like the lights to go off or something.
Yeah, right. Yeah.
But it went by just fine. But now you're in a situation where the database has been modified, and it doesn't have the real credit card data anymore. And as you indicated, all of these applications would have to call in, select stuff from the database, and then possibly have to do something with it. So, for example, the process that printed out your folios when you checked out, right, would now select the card on file and print, mask that out to the last four before they printed it out and slipped it under your door, right?
Right.
And so we had some interesting discussions where with a meeting with like 30 people in it. And I think there were at least 3 vice presidents.
I believe it. I mean, there should have been.
And I was asking the team, who was a consulting team, not a team, not actual employees of the company, what it would take to call one function. So they said to make one function call after selecting this information from the database to generate the portfolio. And how long would it take for them to do that integration? And what would you say their guess was?
6 months.
3-person years.
3-person years.
3-person years.
Okay.
I laughed at them in front of 30 people, including three vice presidents. I said, you know what? Never mind. Don't bother. Because now you can imagine if they did the straight select from the database to generate the PDFs, then the PDF would have the protected number in it, right? So that would be useless for the customer, but as a PCI remediation state, it's not a bad state to be in, right? Because now the PDF production process doesn't have PCI regulatory. Right. And so what we did is my brother worked for me at the time, and I asked him to figure out how to do this. And so he created a Java input stream parser that would parse the input stream of a PDF. And it's a weird structure. Like there's all kinds of like nodes and things that
I've done it. You have to there's a thing at the bottom, and you have to go to the end and get the index, and it's great.
Credit cards that showed up in PDFs could be broken across multiple nodes. So we basically took this, I think it was an open source PDF reader, wrapped it, and then found things that looked like credit cards but weren't in the stream. And so as we read the stream, if we hit one of these, we could then do the transformation into the mask last 4 and then use that to write that back out to the PDF. And so right before the PDF could be handed off to be printed and handed to the customer, we would fix it with this little 100 lines of code that didn't take 3-person years to
did not take 3-person. It was a pain in the butt, but didn't take 3-person years to write.
But it took some thinking, right? And that's, where I am in my career is like, we need to spend more time thinking and less time typing. And we can solve problems pretty spectacularly. The good news is once we hit, sorry?
How many years had you been working as a professional when you were doing this job?
About 10.
Okay. So you were experienced and confident, and maybe things like why are there VPs in the room? Maybe that was or wasn't obvious to you at the time, and all that. But anyway, keep going. Thinking.
At this point, I'd already been through several of the very hard things, like the first whole Earth visualization environment, like Google Earth, but in 1994, with terabytes of terrain information and satellite sensor detection and hyperspectral imagery and pulling video frames off of
on the podcast to talk about that later.
So my point is, I've already been through several things where I was thrust into a situation where there was nobody I could go to. I mean, anywhere in the industry, right, to help answer some of these challenges. So that I think that sort of predisposed me to coming up with clever thoughts on these sorts of things. I was going to say the result of my brother having done that, though, helped us somewhere else, because there were large consulting companies that would literally hand off files encrypted files with like 10,000 credit cards in them. And it was keyed. So at the edge of my customer, they would decrypt it. But now they're in possession of this file with 10,000 credit cards in it. And it would be moved throughout the system and put on the server. And then basically any activity of any of these credit cards would get rolled up into an accounting summary to benefit the consulting company. All of that infrastructure, right, from the capture and the storage of that file to moving it through the system to storing it on the database server and everything like that, all of that would have fallen under the PCI compliance regulatory restrictions and things. Except what we did was, as we took the encrypted file and we used an input stream to de-GPG it, basically, right? We wrapped that stream with a variation of the stream that my brother had created, and then wrote the file back out to disk with the conversion of all the credit cards into the preserving format. So it never hit the disk in an unprotected state, and therefore didn't have to go through the auditing process for how was it communicated and stored, and we didn't have to deal with keys, in places that didn't need it. So now that file could be stored next to the credit card database, and you can now select for those from the database because they're all in the same format. So, it was a good experience, not just because of the challenge, right? The challenges that I faced in other places were unique in the world, but this was a balance between business risk, external pressure, a need to fix and remediate internal systems, and being able to do so without actually modifying that much code. Because again, some of this is on the mainframe, some of it was PC applications, some of this is backend.
How many applications were touched, and were they like Visual Basic things? Were they Java? I mean, back then, what?
It was a mixture of all that. That. I would say it was probably no more than a couple dozen that actually had to be modified.
That's not bad.
Which then also underscores the problem of like ubiquitous credit card risk everywhere, right? They didn't actually need
Fair
it.
Enough.
They were people just did stuff like that because it was easy and convenient, and didn't think about the consequences. So we were able to lay this blanket down on their entire system for a fraction of what it would have cost to like actually remediate each individual system. Again, multiple languages, multiple platforms, multiple OSs, some commercial stuff, third-party applications.
How, without modifying those how much? I don't know if you can explain the architecture here, but you're making a database change, and there's some keys, and the applications did or did not have to change.
The ones that did have to, some of them, if they needed access to the credit card in any form, right, they would have to then reverse the process, and they would be given access to.
Okay. Otherwise, they would have the format preserving thing.
Correct.
None the wiser.
And if they were just passing that through, then they didn't need to be modified. Right?
There you go. Okay, so that's the key that reduces the footprint or the important aspect of the system. Okay.
So when we first proposed this, they're like, "That sounds cool. We don't know how to do that." I was like, okay. So then I designed and built the engine, like the core engine, and made it all work. And I said, okay, now take this and just integrate it into your stuff. We don't know how to do that. Or they weren't comfortable doing it, right? So I said, okay, do you have any standards about web services or anything? No, not particularly. Can we use REST? No, we should probably use SOAP. Okay, well, we'll use SOAP. About a month after we went live, I got a phone call saying, hey, we understand that you have a service that you can put on our bus. I'm like, been here a year and a half, didn't know you had a bus. Yeah, it's great. Okay, cool. What else is on the bus? This will be the first one. Not sure why you need a bus when you don't even have any services, but
tell you, the vendor was incredibly persuasive.
Exactly. It was a great golf game. So, in the end, it was exposed as a soap service. And again, another learning experience for me was after we were in production. I got another phone call from some executive architect I'd never heard of, who told me that he was going to make me redesign my system and remove the implementation on the soap choice that we made, because it didn't allow an optional integration piece of the JAX RPC spec or something like that. Yeah, and it just made me, as my own development as an architect, realize, there's not much value to showing up and telling people that they have to rip out code because maybe somebody wants to use an optional piece of something,
Yeah.
And but he threw his weight around and made us do that. But
he succeeded. Wow. Okay.
Yeah. And that's the thing. It's like, I even asked, like, are there any standards? And when he eventually told me that he hadn't published them, I said to his face, I'm like, there's very little difference between having standards and not publishing them. There's a very fine line
very
there.
Precious. He's sort of architect dread. I am the standard. Really is what was going on there.
And I just realized, that's not the kind of architect I wanted to be. So it was a great experience all around, both from a technical, from a business influence perspective. Like, we had to get people on board with our approach, and so again, as a 30-year-old, not all that senior person, I was having to conduct meetings with vice presidents and senior leadership and things like that. So it was a good experience, and even though it wasn't the most fun thing that I ever did, it's one of the things that I think, from a career development perspective was consequential and very successful. They complained about our rates for a couple of years until we did this, and
I'm sure
the whole thing came in like a couple of $1 million total. Like,
right,
okay,
right.
Well, at least you're good.
Right, exactly. And I can see, and I was going to ask you how this changed you. You already told me that, and I can see this forming younger Brian as an architect, not just with the spur earning, work of functioning in a room with executives and making major changes to a major enterprise, all kinds of legacy systems in a minimally impactful way, and building a great system and all that. But then the interaction with the architect and the sort of needless obsessing over this little special interest detail that just didn't impact anything, but he liked it that way. And you are, I know you as a much more pragmatic and principled in the important way thinker than that these days.
Yeah, and it also helped me think in terms of making changes without making changes, like doing things incrementally and not throwing. There's a tendency to say, let's just throw everything out and start from scratch, and you just can't do that at that scale.
No.
In an enterprise like this. So finding ways to work, changing the tires on the bus as it's moving down the highway, is those are skills worth developing as well. And organizations appreciate people who I think can approach this with a business perspective, right? In terms of business continuity and risk, and not just focus on, hey, if we go to such and such a device or open source project or something, we'll solve the problem. But that could end up costing more and being more risky than taking kind of an incremental approach to fixing things.
My guest today has been Brian Sletten. Brian, thanks for being a part of Confluent Developer.
Sure. Thank you.